in this lecture, we will talk about the example. This example is related to remainder theorem. So let's recall what's the meaning for remainder theorem. A remainder theorem says that a polynomial f of x divided by x minus c, then the remainder is f of c. Here c is a constant. Here the f is a polynomial and can be any polynomial. Okay, any polynomial is fine. And here c, if it's positive, then x minus c looks like x minus 2. And then you will have f of c is actually f of 2. If c is negative, then x minus c is x minus negative 2. So then we have a x plus 2. And then here will be f of negative 2. Okay, so if you say a polynomial is divided by x plus 2, then the remainder is f of negative 2. Okay, now with this in our mind, let's look at this example. This example says that find all values of k. You see k, k, k. So find all values of k such that f of x is divisible by the given linear polynomial. You know, this polynomial contains k, and then this polynomial is divisible by x plus 2. So we know this polynomial divided by x plus 2, the remainder will be f of negative 2. Okay, will be f of negative 2. So let's find out remainder. We know this is given f of x, a polynomial. If we plug in f of negative 2, then the remainder will be that. Okay? Yeah, if you plug in f of negative 2 right here, it's going to be like this. Because this f of x divided by x plus 2 is like x minus negative 2, and the remainder is f of negative 2. So we want to plug in f of negative 2 here, or here, the same. Now, here is x. If here is negative 2, then everywhere else with x should be replaced by negative 2. K is the one we want to find out. So k, x cubed, but x now is negative 2, so negative 2 cubed, plus x squared, replace x by negative 2, so that's negative 2 squared. K squared, that's the coefficient of x, you keep it. And then x replaced by negative 2, and the rest of them has nothing to do with x, so you keep it right here. 3k squared plus 8. This is actually a remainder. Okay, by the remainder theorem, we know this polynomial divided by x minus negative 2, the remainder is negative 2. So this is the remainder. Let's simplify this remainder. Negative 2 cubed is negative 8, because negative 2 times negative 2 is positive 4 times another negative 2, you have a negative 8. The common popular mistake is negative 2 times 3, you got negative 6. Okay, now negative 8k plus negative 4, negative 2 squared is positive 4. Negative 2 times k squared, that's negative 2k squared. Copy this one down here, 3k squared plus 8. Now, keep doing. Well, k squared here. Okay, we combine it. 3 minus 2 is 1. If you want to write 1 here, it's fine. But you know 1 times anything is that thing, so you don't need to write 1. So if it's 1, you just don't write. So here we have a k squared. 3 minus 2 is 1. Then we have a negative 8k, you copy it down here. Two constants together, 4 and 8 is 12. This looks like a quadratic function. Okay, now we get the remainder, simplified remainder. And then by the given condition we know this is the remainder, but this polynomial divided by this one should be with remainder 0. Why? It's because f of x is divisible by a given linear polynomial. Divisible means the remainder is 0. You see, example here is that 6 is called divisible by 3 since the remainder is 0. Of course, if you want to put 2 here, is fine. 6 is also called divisible by 2 since the remainder is 0. Okay? What's the meaning for that? Recall 6 divided by 3. You put 2 here. So here is the remainder. Okay? Remainder is 0. Okay. Now this is our remainder for the polynomial. And then if f of x is divisible by x plus 2, then the remainder f of negative 2, which is this one, simplified, which is also this one, is 0. So this one has to be 0 then. So we'll let this one be 0. Solve for k. Okay. Now this is like the quadratic equation. 12 is negative 2 times negative 6. That's 12. 2 negatives is positive. Add together, you should have a negative 8. Negative 2, negative 6 is negative 8. Add together. So you can factor the left-hand side like k minus 2, k minus 6. Okay, that's equals 0. From here we know k either will be 2 or 6. So 2 is here, 6 here. Because you plug in 2, you have 2 minus 2 is 0. So this term is 0. 2 minus 6 is negative 4, but you know 0 times negative 4 is 0. Okay? So if one of them is 0, it crashes all the thing. All of them is 0. So is the case for 6. You plug in 6, 6 minus 6 is 0. 6 minus 2 is 4. 4 times 0 is 0. So we have a 2 and 6, 2 values. Now, up to this far, we have find all values of k. That's 2 and 6, such that f of x is divisible by the given linear polynomial x plus 2. Okay, yeah, you may plug in 2, replace k with 2, and see how does the polynomial look like, and see if this polynomial is really divisible by x plus 2. You can do the same for 6. Okay, I'll see you next time.